Hello, welcome to IT Lundy. This is part 3 of Windows Server 2012. Topics for today around file and storage. We will be covering data deduplication, storage spaces, thin provisioning and trim storage, high performance, resilient file system, iSCSI, high availability block storage, unified remote management, data center diskless boot, storage management, multi-terabyte volumes, encrypted hard drives, rapid and efficient data management using intelligent storage array, and then server for NFS data store, and the last part will be users device affinity. First part, data duplication, deduplication. Windows Server 2012 deliver data deduplication, the act of finding and removing duplication within data without the need for compromising its fidelity or integrity. Technical overview. The goal of data deduplication is to store more data in less space by segmenting file into small 32 to 128 kilobyte and variable size chunks, identifying duplicate chunks and then maintaining a single copy of each chunk. Redundant copies of chunks are replaced by a reference to a single copy. In addition, chunks are also compressed. Files are no longer stored as independent streams of data, but they are replaced with stubs and point to data blocks. The result is an on-disk transformation of each file as shown in the next slide. We can see the files before and after the data duplication, and how we are basically shifting and arranging the data and reclaiming the white spaces. Performance for data duplication. Windows Server 2012 implement state-of-the-art subfile data chunks and compression to deliver optimal data deduplication. The result is an on-disk transformation of each file as shown in the preceding slides. Files are no longer stored as independent stream of data. They are replaced with the stubs that point to the data blocks stored within the common chunk store. Deduplication can be applied to a variety of workloads with typical saving between 50 to 90%. The implementation is transparent to the primary workload on the server. This is achieved by minimizing the input impact through scheduled and selective optimization and minimizing server impact low resource. Further, the implementation is strongly optimized for high data integrity. This is achieved by performing data integrity validation on all data as well as the metadata by ensuring redundancy for all metadata as well, which is popular data chunk. Windows Server 2012 servers that enable deduplication as well as branch cache apply the same algorithm to on-disk and on-wire saving and benefiting from faster download times and reduced bandwidth usage over wide area network. This is typical data deduplication saving in store, DHD library, software deployment share, general file share, and user home folder or my doc, and we can see the percentage of the saving between 0 to 100, and especially around the VHD library, it's around 90%. Second part is the storage spaces. Storage spaces, what they are basically, storage spaces in Windows Server 2012 enable cost-effective, optimally used, highly available, scalable, and flexible storage solution for business-critical virtual or physical deployment. Windows Server 2012 delivers storage virtualization capability based on industry standard storage for single node and scalable multi-node deployment. Storage spaces, conceptual deployment module, physical or virtualized deployment, integrated with other Windows Server capability, Windows virtualized storage and physical storage, either SAS or SATA or JPOD, utilizing SMB direct or hyper-converged deployment. Later on, we will be talking about the differences between 2012 and 2016 server, especially around STD. In order to implement STD, these are the requirements. For single node deployment, we need Windows Server 2012, serial ATA, SATA or SCSI attached disks, or bench of disk, which is JPOD. For multi-node cluster shared storage deployment, we need 2 or more servers running Windows Server 2012, requirement as specified for failover clustering, and Windows CSV, SAS connected or JPOD that comply with the Windows certification requirement. Core technology. Storage space delivers storage virtualization capability within Windows 2012. The storage stack has been fundamentally enhanced to incorporate 2 new subtractions: storage pool and storage spaces. Storage pools are an administrative unit of physical disk. Pools permit storage aggregation, elastic capacity expansion, and delegated administration. Storage spaces are virtual disks with associated attributes such as desired level of resiliency, thin or fixed provisioning, automatic or controlled allocation on heterogeneous storage media, and granular administrative control. Storage spaces are manageable through the Windows Storage Management API in Windows Management Instrumentation (WMI) and Windows PowerShell, and through the File Service GUI in Service Manager. Storage spaces is completely integrated with failover clustering for high availability, and it is integrated with CSV for scale-out deployment. Storage pools, multi-tenancy resilient storage, and pair pool. These are the features of STD. Storage pools are the fundamental building blocks for storage spaces. Given a set of physical disks, an administrator can create one pool by using all the available disks, or multiple pools by dividing the physical disk as required. To maximize the value from storage hardware, the administrator can map storage pool to a combination of hard disk as well as solid-state drives. Pools can be expanded dynamically by adding additional drives, thereby scaling to cope with the continuous data growth. Multi-tenancy administration of storage pool can be controlled through ACLS, which is access control list, and delegate on a pair pool basis, thereby supporting hosting scenarios that require tenant isolation. Storage spaces follows the Windows security module and can be integrated with AD or Active Directory domain services. Resilient storage. Storage spaces support 2 optional resiliency modes: mirroring and parity. Pair pool support for disks are reserved for replacing failed disks. Host pairs Background scrubbing and intelligent error correction allow continuous service availability despite storage component failure. Continuous availability. Storage space is integrated with failover cluster. One or more pools can be clustered across multiple nodes within single cluster. Storage space can then be installed on individual nodes, and the storage will seamlessly fail over the different nodes when necessary in response to a failure condition or due to load balancing. Integration with CSV permits scale-out access to data. Optimal storage use. Server consolidation often results in multiple datasets sharing the same storage hardware. Storage spaces support thin provisioning to share storage capacity among multiple and related data sets to maximize capacity use. Trim support permits capacity reclamation when possible, and operational simplicity, remotable and scrapable management is permitted through Windows Storage Management API, WMI, and Windows PowerShell. Storage spaces can also be managed through the file service role in Server Manager. My favorite method is Windows PowerShell, and I will suggest and recommend to make yourself familiar with PowerShell. That's all for today. Just a recap, we spoke about storage spaces, high-level technical design recommendation, and deployment best practices according to Microsoft. Thank you for listening to part 3, and I shall see you at part 4 of Windows Server 2012 features. Thank you.